Hello everyone, my name is Alan Puchat and welcome back to the Smart Contract Development tutorial of MultiversX, where today we will continue our journey on creating the Cryptozombies tutorial. This tutorial, you can also find it on a more step-by-step approach on cryptozombies.io. Today, what we plan to do is to talk a bit about addresses inside contracts, limit function calls which require, talk a bit about spread traits in the idea of which we would like to split our contract, which the code starts becoming a lot. We would like to split in some more modules. And lastly, we'll talk about proxies, which are basically calls of other contract endpoints from within our contract and their respective callbacks. Without further ado, let's get started. First thing that I would like us to do is to talk a bit about ownership. Right now, we are creating a new zombie and we are storing it inside the contract. But it would be amazing if in this process, we would also be able to map it to an address in the idea that a zombie can be owned by a person, by the person creating it. In order to do that, let's start creating a new mapper, which we will call on zombies. So we will like it to be indexed by an address, and this address should be the owner. Manage address. And yes, you should keep not one value, but multiple values of view size, in the idea that certain address might own multiple zombies. For now, we are using the single value mapper, which allows us to keep only one value. So today we will start talking about a new type of mapper, which will be set mapper, or its slightly better counterpart, unordered set mapper. Unordered set mapper and mapper behave kind of similarly. The difference is that unordered set mapper makes the swap delete operation, which is kind of way cheaper. What you usually do on an array when you want to delete an element from an index X, for example, you look on the array, you find the element, you take it out, and all the other elements are shifting into its position. Well, by swap remove, we are actually taking the last element and put it over the element that we want to delete and just decrease the size of it. That means the complexity of swap remove is O1 compared to ON, which is the normal delete. The only element that comes, the catchy element that comes with unordered set mapper is that we lose the capacity to know the order of the elements. But in our case, we don't actually care, since a person can own multiple zombies and we can just access them by an index. Yeah. Now that we created our own zombies mapper, inside create zombies, let's create a new variable called color. And in this variable, let's get the address of the color of the endpoint through self dot blockchain dot get not balance but color. There we go. And now this color, we need to use it to get the index of the zombie that was created. The index, we get it inside create zombie, here inside the update of last zombie last index. So let's just give this color as a parameter to the create zombie function as well. Create zombie now has also owner as a managed address. So, and here inside our update, we'll just self dot on zombies owner dot insert ID, or specific. What I mean by ID, I actually mean the reference ID. Reminding UI, because in our update ID, we get it as a mutable reference, and we need it as a value in order to put it inside our mapper. So what we're actually doing, the reference it, and it automatically copies it and give it to the mapper. Right. Now, let's say that a certain address can own multiple zombies from other sources as well, but we want to limit the use of create random zombies so that you can have maximally one zombie created for this. What we would need to do is to make a require, where we give it to the condition. The condition would be that own zombies of owner doesn't own any zombies in order to allow him to create zombies. So cell dot on zombies of owner is empty. Otherwise, we'll just throw an error. You already own a zombie. Okay. Now there's a small catch about it's not owner, it's color. Yeah. There's a small catch about this color right now, because on zombies takes this manage address as an index and looks how many zombies or what zombies it owns. But we use it in two places. We use it here, and you also pass it to create zombie in order to afterwards insert a zombie inside of it. In order to do this, to get rid of this error, which tells us clearly that the value of color moves to here, we give it to on zombie, and from there we don't have it anymore. One of the ways in which we can improve this code is actually make owner as a manager, a reference to a managed address. What happens in this case? We give a reference to our managed address to owner zombies in order to see if our address owns a zombie or not. And after that, the value returns back to caller and can easily pass it to create zombies as well, so that afterwards we can insert a zombie to this address if it doesn't have it. Great. With this out of the way, we can start talking about how to make our code a bit easier to read. As you see, we already have a lot of code in only one file, and we would like to actually split all this code in multiple files so that it's easier to review for the persons who are looking on our code, and also easier for us to keep track of our code or of our functionalities. What we'll actually do is, well, I'll just create a new file. For start, let's just move the whole zombie structure in its own file. So zombie.rs. And in here, we'll basically take all of this side. The structure, we don't need it here anymore. But now we need to import our zombie to be visible also in our main contract, and we do this with mod zombie. And afterwards, use zombie, no instructions. Furthermore, right now, because our zombie is in a separate file, we don't have access to its fields anymore because they are private, and this is the reason why we also need to make this ones public. Okay. Next, let's actually move all this logic of creating a new zombie in a new module. We can call it zombie factory. There is. Here we need to create a new trait. Trait zombie factory. And inside our module, we will move all this logic of creating zombies. And we also need to import our zombie factory as a module here. Mod zombie factory. Oh, also we need to declare the trait as a module, just like we have the contra trait annotation. We also have a similar one for a module, which is MultiversX SC. And after that, what we have left to do is to add this module, which is a super trait. That's how it's called in Rust, to our contra trait zombie factory. Then we also need to bring our import. I don't think we need the derived imports for factory. We don't need derived imports. And the last element that it says that it doesn't have access to is the storage element, the storage units. But that's fine because I'm going to actually take them and move them in their own module as well. Storage terms. Trait storage module. Here. Import. Now we need to add it over here. Storage. Module. And also to the main contract in order to be visible in the other modules that we have. Now the plus storage. Oh yeah, and mod storage. No endpoints in storage. What are we missing? Oh yeah, we need to import zombie. In the factory, yeah, he doesn't know about storage, so I'm going to import storage. Same with zombie. Where else? Cannot find attribute. Storage map and this scope. Ah, yeah. Because we forgot the module annotation. This. Yeah, everything's solved. And we don't need the zombie anymore in our init. There we go. That's more like it. Now we have our zombie in its own separate file. Everything that is related to creating the new zombie is in Zombie Factory. We have the storage module, and of course we have our main contract, which just gathers everything together. Cool. Now, let's create a new module called Zombie Feeding, in which we will start developing our new zombie logic, which would be zombies will start feeding on certain elements or zombies or on other stuff. And by doing this, they will multiply, and probably they will also increase their stats, or we will see on the way. So create new file, we'll call it zombie feeding trace. Just not to forget about it, we'll already add it as a module in our main contract. Feeding. Even though we don't have the module yet declared, I'll just add it. We will call it zombie feeding. And inside zombie feeding, let's actually cheat. Copy this straight up from Zombie Factory. Probably we will need a storage module, so I think I'll just leave it there for now. And since I already did that, let me actually get this. Right. Let's start making right now a new endpoint called feed and multiply. And the logic would be that the owner of a zombie can order a zombie to attack or to feed on a certain DNA. And by doing this, it will create a new zombie for the certain mode. So let's start making a new endpoint over here. We will call it function feed and multiply. Of course, it will get self as the first argument, having access to everything the trait owns. Zombie ID, which zombie will order to feed his size, and the target DNA. Of type US64. First of all, we need to make sure that the one ordering the zombie to feed on the DNA is actually the owner. We should not allow someone else to give orders to the zombie of a certain person. We will get the color just like we did before, equals self dot blockchain get color. Make a require for color. We will need to make sure that the color is the owner of the zombie. Right now, we don't have anything in our storage to tell us who is the owner of a zombie. We only have the mapping from the other side. We know from the owner what zombies he owns, but we don't have the other mapping. So in order to continue this function, let's actually make this mapping. It should be a single value map. because each zombie is owned by one certain person, only one person. So we'll call it zombie owner. And we give it the ID of the zombie, and it should return us the address of the owner. Many thanks. The first place where we need to actually work with this zombie owner would be in zombie factory, where we create zombie. Once we create a zombie and say that a certain owner owns the zombie, we also need to do exactly the opposite, that specify that the owner of the zombie is the address that we get it from the caller. Now that we have this mapping, we can say that the caller needs to be the owner of the zombie itself, that zombie owner of zombie ID. That's, yeah. Otherwise, we'll just throw an error saying that only the owner of the zombie can perform this operation. Next, once we make sure that the zombie is given orders by his owner, let's actually get the zombie from our mapper. So let my zombie equals cell dot zombies of zombie ID not get. I think we're losing zombie ID somewhere. Let me check. I is expecting usage, so we don't need to reference it. One thing that you need to know about this, why in this case, for example, we don't need to clone it and we can just pass by reference, is because useSize is one of the types that implements copy. In the one when we give it from a place to another, it just makes a local copy, and it doesn't consume the whole object. Our managed types don't have the copy trait. That means we are usually using the reference in order to access them. Okay, now that we have our zombie, let's create a new zombie by infusing the two DNAs. What we'll actually want to do is to create a new DNA, which will be the average of my zombie's DNA and the target DNA. Before we do that, I think it would be a nice idea to actually make sure that our DNA is a valid DNA. That means we need to make sure that our DNA is not bigger than the max DNA value possible. When we do that, we can just apply the modular operation on it and with the maximum value, and in this way we'll make sure that it's always smaller than the max value. So the max DNA value equals 64 power 10 64 depend on the power of the DNA digits. So we also need to get the DNA digits. Let DNA digits equals self dot DNA digits dot get DNA digits as U32 because it asks for the second and the expression to be a U32. And now, in order to make sure that our DNA is valid, let write DNA target DNA equals to target DNA onto max DNA. And this would be our new verified target DNA. And the DNA that we will have the new zombie will have will be the average of my zombie's DNA, the one that consumes this DNA, and the DNA that we just verified that's a valid one. So let new DNA equals my zombie dot DNA plus verified target DNA divided having that. Now we can just self dot create zombie. We don't have access to create zombie because it's inside zombie factory, so we need to import it. Let's create zombie factory. Zombie factory. Zombie. And let's see, zombie DNA wants 3 arguments. The first one is the address of the new owner. That will be our caller. Afterwards, it wants the name of your zombie. So let's just make a new manage buffer. Let nil name equals manage buffer from a byte array. I don't know, let's call it for now no name. This will be our new name. For now, we'll see later if we change it. After that, the DNA, new DNA. And we're done. Now that our zombies are able to feed and multiply by giving them a DNA, it's maybe time to decide what this DNA is. Of course, they can feed a zombie, they can feed on a human, but in order to communicate with another contract, that zombies are also eating CryptoKitties. Luckily for us, I have here the structure of how CryptoKitty might look like. Let's say that we have a CryptoKitty that looks something like this. And this CryptoKitty contract has an endpoint called getKitty, which returns us a kitty. What we would be interested from Next for kitty would be maybe the genes. The genes being the closest we get to a DNA, and this is exactly what we can give the zombie to eat and get some really nice mutation to get a new zombie with maybe kitty ears or something. That'll be very funny. In order to make all of this possible, it's time for us to start defining a proxy. A proxy is basically a module containing some of the code of the contract, mostly gets the definition, the prototype of the endpoints that we want to call. In our case, we want to use an endpoint from the CryptoKitty contract, which is called getKitty, and which should look something like this. So you just imagine that we have a trait CryptoKitties having this endpoint that we are interested in, which gives us kitty. And this trait, we need to define it. It's not a contract. I mean, it is a contract, but here, in our case, it behaves like a proxy. So it's MultiversX SC proxy. And everything that we define here needs to be wrapped inside a new module, which we will call CryptoKitties proxy. Actually, we can just put the name of the module straight up on the file. That's CryptoKitties proxy. And now in seeding, we will need to create ourselves a new proxy. Which is basically an endpoint from another contract, or the reference of an endpoint from another contract. Self, the call, this should be the address of the contract that we're calling. So managed address, and it returns us proxy self crypto proxy and the proxy from proxy gets this. Probably we need to import this. Yeah, we need to give it to the main contract. But see, and now we can also reference here. Use create and there we go. And now that we have our proxy, we can actually create an endpoint by which we allow our zombies to feed on a kitty. Let's make a new endpoint. And we will call it feed on kitty. here we will specify the zombie that's going to feed. So first of all, self zombie ID size. But we also specify the kitty on which the zombie will feed. So kitty ID, which is also a size. Inside here, we will make a call to our CryptoKitty proxy. And after that, make a callback so that after we get the kitty from the CryptoKitty contract, we will take the DNA from his genes and give it to the zombie and apply and call feed and multiply. We also need a place where to from where to take the CryptoKitty smart contract address. I think we can solve that very easily with a new storage mapper. Let's just make it here for now. Storage mapper. So yeah, address crypto which gets a self returns as a single value mapper of a containing the managed address, which will be the address of our CryptoKitty smart contract. And now from here, first thing we do, we'll get the CryptoKitty smart contract address. Let go self dot right CryptoKitty smart contract address dot get. And now we can just call the proxy by self dot kitty proxy. The address is the address that we just got it from before. So CryptoKitty smart contract address. From here, we will call getKitty. It's exactly the endpoint that we are interested in, that we got it here in the definition of the proxy. The ID of the kitty that we pass it as a parameter to the endpoint. After that, we will perform an asynchronous call with callback, and our callback function we will just define for now a new callback, and we will see later what we will do in it. So let's just make a short callback. Okay. Let's call it function get getKitty callback, which gets a self a result, which will be a manage async call result containing kitty. And we also need a zombie ID. Know exactly the zombie that fed on the kitty. That's what we want to do. From inside is get kitty callback. After we get the kitty genes, to call feed and multiply, giving the zombie the possibility to feed on the kitty DNA. He doesn't know who's kidding. It's fine. Okay. And with callback, and the callback will be self dot get query callback. Oh, sorry, it's get callbacks dot get query callback. And from here, results shouldn't be here. Oh, this because I need to mark it as a callback result. So here I will also put an annotation or callback result. Not callback, it's call result. There we go. This way he will not ask for it. And we're just giving the zombie ID as the new, as a parameter to the callback. And after that, just call and exit. And we're done. Inside our callback, what we actually want to do is to look to the result to see if we manage to get the kitty genes or not. So we can just make a match result. Can be either a manage a single result containing okay and returning us the kitty, which in that case we will do something with it, or a managed asynchronous call result having an error of any kind, in which case we'll just terminate the execution without doing anything. Here we would like to get the kitty DNA from the kitty, so let kitty DNA equals oh yeah. The genes. We go, and once we get genes, we can call self.feed and multiply zombie ID and the target DNA being the kitty DNA. One last element. Okay, we don't need this zombie on the script because we're not using it. We'll just very fast run a variable check. Yeah, if you are not interested in building the contract and you just want to check everything is okay, you can just run cargo check, and this will not update, not generate your ROSM file, but it will just check that everything that you wrote, your code is okay and is compiled. Yeah. Okay, we successfully finished also the second chapter of the Cryptozombies tutorial. Thank you very much for your attention, and I'll see you in the next one. Bye-bye.